So if we have an operator in between the two operands, then we can call that as a infix expression. Division is an operator, and you can see here in the stack we have a multiplication symbol. Next I have a division. Division and multiplication both has the same priority. Then it can't be placed together. So this needs to be popped out. If I found any operand that needs to be moved to the stack, let me consider this as a stack. So now I have 5. Hello everybody, a warm welcome to one and all. Welcome back to the session 2 of chapter 2, and we are in the unit 2 of B.Ca.'s semesters 2 of subject called Data Structures Using C. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So before getting into our today's session, that's all regarding stacks. Let me have a quick recap of our previous session. As we discussed in the session 1 of this chapter, we had a discussion regarding the stack concept. In that we got to know what do you mean by stack. Stack is an ordered collection of elements where insertion and deletion of an element both will going to take place at a same end. Then we are calling that as a top of a stack. That is all regarding definition. And we got to know how we are going to represent a stack, and also what are the operation can be performed on a stack. We can have a stack, push, pop, peek, is empty, and at last we got to know regarding the size of a stack. Then we also discussed regarding what are the applications of stack. So application in the sense that specifies where and all can we use this concept. So in our today's session, we're going to have a look regarding this infix, postfix and prefix notation. What do you mean by it? That I will be discussing. Along with that, we're going to convert from infix to postfix expression, that too by making use of a stack, and also evaluation of postfix expression by making use of stack, and at last we'll see what is the application of stack in a function call. So already we know, right, what do you mean by function, how it will going to be helpful in the function call, that I will be discussing at the end of today's session. So let me get into the session with respect to this infix, prefix and postfix notation. Before that, you must know what do you mean by an arithmetic expression. So, if you are giving a facial expression, is that considered as an expression? No, right? When it comes to the arithmetic expression, it will going to comprise of both operators as well as operands. Then, when we are performing certain operation, then it will going to return a single value. For example, let me consider sum is equal to a plus b. Right? Sum is equal to a plus b. So here, can you just specify what are the operators we have and what are the operands we have? What are the symbols we have that is considered as operator? Here I have equal operator and then plus operator. And what are the operands we have? We have a, b as well as sum. So then I can call this kind of scenario as a expression. It comprises of both operand as well as the operators, and it may consist of, here operand consists of constants and variables that can vary, or it can have a constant value, and operator can be plus, minus, multiply, divide, modulus, parenthesis, equal. So we have different operator that can also be considered as a symbols or operator. Then what kind of expression it can be? It can be infix expression, postfix expression and prefix expression. We'll see about each kind of expression one by one. So when it comes to infix expression, so we already know that an expression is all about a combination of operator as well as operand. Then what is this infix? In the sense, if an operator is in between two operands. So if we have an operator in between the two operands, then we can call that as a infix expression. So here you can see the example a plus b. So here plus is an operator which lies in between the two operands. Here a and b are the operand and plus is an operator. Then what is postfix and prefix? So we have a prepaid and postpaid. Pre in the sense which we are paying it earlier. Post in the sense after that. Right? So here postfix expression if an operator follows the two operands. So if the operator is coming after the operand, two operands, then we are calling that as what? Postfix expression. What is the example? AB plus. Then what could be in prefix? It will be, that means operator will come first, then that will be followed by the two operands. So when it comes to the prefix expression, an operator precedes the two operands, then that is considered as a prefix expression. So here you can see that plus AB. These are regarding postfix as well as infix notation. Fine. Then now we can see here we have an algorithm that is used for conversion of infix to postfix expression. So now I have an infix, that means A plus B. Now I wanted to convert that into postfix, that is AB plus. Then how we are supposed to do that? What are the steps we have to follow in order to convert from infix to postfix? First we'll see the step 1, that is examine the element in the output. So you just consider A plus B is my input here. If it is operand, so if it is operand, any constant value variables and all, output it. So here what I have at first, A, right? That is my input. Then I need to output that at the resultant. Now it is A. If it is opening parenthesis, push it on the stack. So if my expression is like this, then we have to put this parenthesis or any operator into the stack. Operand should be to the output and operator should be to the stack. Next step, if it is an operator, then if the stack is empty, push the operator on the stack. Remember, operand to the output and operator to the stack, that is conversion from infix to postfix. Then if the top of stack is opening parenthesis, push operator on the stack. So already if I have a opening of parenthesis in the stack, then we need to push that into stack. For example, if it is plus, then that will be pushed into stack. Then if it is has a higher priority than the top of a stack, push the operator on the stack. So if it is having higher priority, first you must know what are the priorities we have for a operator. That I will be discussing in my coming slides. As of now, so if it is having a higher priority than the top of a stack, then push the operator on the stack. So below we have a lower priority operator, then I can insert that high precedence operator into the stack. So if I have a highest priority here in the top of a stack and if I am trying to push a lowest priority, then that is not possible. Next, otherwise else pop the operator from the stack and output it, and we have to repeat the same step. That means if you are getting a operator and if you are getting a opening and closing of a parenthesis, then we have to follow this step. In the step 5, if it is a closing parenthesis, this is what closing parenthesis, then pop the operators from the stack. For example, already I have a opening parenthesis in a stack, then I have inserted plus operator. Now I found closing of a parenthesis. If I found closing of a parenthesis, then pop the operator from the stack and output them until an opening parenthesis is encountered. So if I got like this, then this needs to be popped out, right? Then this will both get cancelled, then plus will going to be popped out. Then pop and discard the opening parenthesis and closing parenthesis. In the step 6, if there is no more input, then go to step 1. So if there is no input, then no need to scan the element from left to right. Then if there is no more input, pop the remaining operator to the output. Whatever we have in a stack, that needs to be popped out to the output. Now I will explain one example, then you will be able to understand it. So before that, we will have a rules for conversion of infix to postfix expression. As I told earlier, we cannot place lowest priority on the higher priority. So here are some of the rules you can see. We have a priorities of the operator. Here you can see that we have a dollar symbol and caret or circumflex that will going to have a higher priority, and multiplication and division both have a same priority, as well as plus and minus have a same priority, that is least priority. So, and one more rule, no two operators of a same priority can stay together in the stack. So we are not supposed to take two operator of a same priority in a stack. So one needs to be popped out. Then lowest priority cannot be placed before the highest priority. So these are the rules we have to follow. By looking into these rules, we will have a conversion from infix to postfix. So here you can see the expression 2 into 3 divided by open parenthesis 2 minus 1 closing of parenthesis plus 5 into 3. So then how we are going to do this? In order to have this conversion, first I must have an expression or a symbols, then stack, then postfix expression. Let me consider one by one right now. First let me consider the symbols here. Then what we have? Stack. At last we have a output or a postfix expression. Fine. So now I have a first letter as 2. So if we are getting a first letter as 2, then that means if I am getting a operand, that has to be stored in the output or a postfix expression. So let me consider here, then into. So if I found any operator that needs to be pushed into the stack. So now I have only 2 in the output. Next I have a 3. So 3 is the operand that needs to be stored in this place, 2, 3. So here 3 is an operand, so that has to be moved to the output. So next we have a division. Division is an operator, and you can see here in the stack we have a multiplication symbol. Next I have a division. Division and multiplication both has the same priority. Then it can't be placed together. So this needs to be popped out. So now what I have in a stack? A star that was there. So now we have 2, 3 and asterisk symbol. So now I can push this divide symbol into the stack. Next what we have? Opening of a parenthesis that can be placed in a stack and it remains same. Then we have a operand called 2. So if I found an operand that needs to be stored in the output or a postfix expression. So now it will be 2, 3 into 2. Next I have an operator called minus. So minus can be placed here and this will remain same, 2, 3 into 2. Then we have an operand called 1. So here divide, opening of parenthesis, minus, if it is an operand that needs to be stored in the postfix expression. So it will be 2, 3 into 2, 1. After that, I have a closing of parenthesis. So when I found a closing of parenthesis, whatever the symbol is present within that opening and closing of a parenthesis should be popped out, and that opening and closing of a parenthesis should be discarded. So now how it will be? Divide, opening of parenthesis, minus, then closing of parenthesis. Then this minus needs to be popped out. Then how it will look like? 2, 3 into 2, 1, and I have a minus here. So in the stack now we have only division that you can see here. Next we have a plus as an operator here, but you have to see already I have a division symbol in the stack. But we cannot place lowest priority on the highest priority. This plus has a lowest priority than the division. So this division needs to be popped out. So now it will be 2, 3 into 2, 1 minus divided by. Now I can insert this plus to the stack. Then I have an operand called 5. So the 5 will going to be directly moved to the output or a postfix expression. Then I have a star. So we have a star here. Plus as a lowest priority, so I can place highest priority, that is multiplication symbol. So the stack will be plus and asterisk symbol, and the postfix expression will be 2, 3 into 2, 1 minus divided by 5. Then we have a 3, that is an operand. So that will going to be stored in the postfix expression. Then you have to examine, do we have any other elements here? No, right? Then we have to pop out all the operator whatever we have in a stack. So first multiplication symbol or asterisk will pop out, then plus. The output will be 2, 3 into 2, 1 minus divided by 55, 3 asterisk symbol plus. So this is the conversion from infix to postfix. So why I am considering this as a postfix? Why? Because after the operand we are having a operator. So that's how we are going to convert from infix to postfix. We'll see one more example here. So here we have a expression. First I need to consider a symbols. Next I have a stack column, and we have a output or postfix expression. Now I have a opening of parenthesis that needs to be moved to the stack. As of now we don't have anything in the postfix expression. Next I have an operator called A. So A needs to be pushed to the postfix expression. Next we have a plus, opening of parenthesis, plus and A remains same. Then we have a operand called B. So B needs to be pushed to the postfix expression. Next we have a division. So here you can see that this plus has the lowest priority, then I can place the division, no problem. So opening of a parenthesis, so this plus and division will be there. So now this remains as it is. Next we have a operand called C. So if it is an operand that needs to be stored to the postfix expression. So here A, B, C, that's when remains same. Next what we have here, after the C we have a multiplication symbol. Already I have a division symbol here. Both has the same priority. Both cannot be placed together. So this division symbol should be popped out. Then the expression will be like A, B, C divide. Okay. So now I can insert this star to the stack. Let me continue here. Then again it will be symbols. Then we have a stack, then it will be output or a postfix expression. Okay, consider these are the symbols. So we are done till here, right? Next again I have a opening of parenthesis. In the stack right now we have opening of a parenthesis plus and we have a multiplication symbol. Again I have a opening of parenthesis. Fine. In the postfix expression we have A, B, C divide. Then I have found this opening of parenthesis that got over. Then we have a operand called D. So if it is an operand that needs to be moved to the postfix expression, then we have a plus symbol. So we have a plus symbol that will be in the stack right now. This will remain same, ABC slash divide D. Then I found a plus. After that we have a operand called E. Then this will remains same, ABC slash D. Then we have a E. Then I found this closing of a parenthesis. So if it is a parenthesis, closing of a parenthesis, then whatever the operator is in between that closing and opening of parenthesis should be discarded and it needs to be moved to the postfix expression. So it will be A, B, C, D, E. Then we had plus here. Then after this we have minus symbol. So here you can see that we have a star, that is highest priority. I cannot place lowest priority before the highest priority. So this needs to be popped out now. So now what I have? Only plus and star. So star will going to be popped out. A, B, C slash D, E plus. Star got popped out. Then you can see I have plus. So here plus and minus has same priority, then I can't hold this plus in the stack. That is also needs to be popped out. Fine. So now I have only, so this plus got popped out and it is stored in the postfix expression. So after minus what we have? F. F is an operand that needs to be stored in the postfix expression. A, B, C slash D, E plus asterisk plus F. Fine. Then we have a closing of parenthesis. So now I have opening of parenthesis and minus in the stack. Now I have a closing of parenthesis. If I found a closing of parenthesis, then I need to discard the symbols whatever we have in a stack. So now it needs to be popped out and it will be like this. Let me write the expression, postfix expression here. A, B, C slash D, E, then plus asterisk symbol plus F minus. This is what the converted postfix expression for the given input of INFIX. This is how we are going to convert. I hope you all understood. Let me move to the next concept, that is evaluation of postfix expression. How we are going to evaluate? So when we are evaluating it, at last we are going to get only one value as a resultant. First, start reading from left to right and push the operands into the stack. Now, this is just a reverse. If it is conversion, then operand will be in the postfix. If it is evaluation, then the operand will be in the stack. Then if an operator occurs, then pop last two operands from the stack and perform respected operation. So as of now, you just understand what are the steps we have. Along with the example, I will teach you. Then in the step 3, operand 2, operand 1. Then push the resultant into the stack. So if we found an operand, then that needs to be moved to the stack. If I found an operator, then I need to pop last two operand of a stack. Then we have to perform the operation. You can see the example here. 562 plus into 12, 4 slash, that is divide, at last minus. So here we have a scanned input or a scanned symbol. Okay. Next, let me consider a stack, and this is what the resultant or output. Okay. So these are the 3 columns I have. What is the first value? 5. So if I found any operand that needs to be moved to the stack, let me consider this as a stack. So now I have 5. Next, in the output, now it is 5. Then I have a 6 as an operand that needs to be pushed to the stack. Then this will be the, this was the top. Now this is the top of a stack. Fine. Next, I have 2. That also needs to be pushed into the stack. So now this 2 become the top of a stack. Fine. So here I have 5, 6. Here I have 5, 6, 2. Fine. Next, what I have? Plus. If I found any of the operator, then I need to pop first 2 operand from a stack and I have to perform the respected operation. So now I need to pop this 2 and 6. 6 is the operand 2. This is the operand 1. So 6 plus 2. We have a plus operator. I have to perform a operation called addition. 6 plus 2 will be 8. So now what we have in a stack? 5 and 8. So now it becomes 5, 8. Next, what we have? Multiply symbol. So in this, if I found an operand, then that needs to be moved to the stack. If I found an operator, then I have to pop the last 2 at the top of element. Then we have to perform this operation. In the stack, now I have 8 and 5. Next, I need to do the multiplication. 8 5s are 40. So now this both 8 and 5 will going to be multiplied. Then we got 40. 40 will be in the output or a resultant. Next, we have a 12 here. Let me write here itself. So when I found this 12, 12 is an operand, so it needs to be in the stack. So as of now, what I have in a output, that is 40. So 40 is there. Now I found 12. After that, again we have a 4. 4 is also going to be stored in a stack. 12, 4. Okay. So now I need to perform the operation divide. So divide is a operator. So I need to pop the last 2 element or a topmost 2 element. Then we have to perform an operator. This is an operand 2. This is operand 1. So 12 by 4. Then we are going to get 3. So as of now we have 40 and 3 in the stack. So 40, 3. Next, what I have? Minus symbol. So in this minus symbol, what we have to do? So if it is an operator, then I have to perform the pop operation. Then I need to do the calculation. So this will be the operator to 40 minus 3. Then we are going to get 37 as a resultant. We don't have any other input values here. So the output will be 37 for the given evaluation of postfix expression. This is how we are going to evaluate. Next, we will have one more example here. 2, 3 into 5, 1 divide plus. Let me consider. First, this is my scanned input. Next, we have a stack. And we have a output or a resultant. Fine. Next, 2. 2 is an operand. So that needs to be moved to the stack. So now next we have a 3. 3 is also operand. So again it needs to be pushed to the stack. So this is the top of a stack now. then 2 comma 3 I have in output right now, then multiplication symbol. If I found an operator, then we have to pop the first two element, then we have to perform the operation. So now it will be operand 2 into operand 1. So it is of 6 now, 3 2s are 6. So now I am going to get the resultant as 6. So as of now I have 6 in my stack. Next I have a 5. So 5 is an operand, then that needs to be moved to the stack. 6 and 5 we have here. Then again we have 1. 1 is an operand, so that needs to be moved to the stack. 6, 5, then 1. Okay. Now I found a slash, that is divide symbol here. If I got a operator in the expression, then we have to perform the operation. So as of now, at the top of a stack, I have 1 and 5. Then we have to perform this operation. So 1 5 is a 5. So this slash returns the quotient value. That's why the resultant is 5. So as of now, what I have in a stack? 6 and 5. So here we have a 6 and 5, and at last we have a plus. Plus is an operator. Again I have to do the addition operator. Then it will be 11. So here 11 is the output, or after the evaluation we got the resultant like this. This is how we are going to evaluate. I hope you all understood. Let me move to the next concept, that is application of stack in the function call. As we know that function is what? It is a set of statement which will going to perform a particular task. So we have a calling function and a called function, right? We have a calling function and called function. So in the calling function, I am sending the input, what are the parameter I require and what is the performance needs to be done. Everything will going to be sent from calling function to the called function. So called function will going to perform the operation. Once the operation is done, it has to send the resultant back to the calling function again. Then within this scenario or within this procedure, how this stack will going to be helpful for us, you can see here, use of stack is during in the function call and return process. So here we are going to use a stack. So before the resultant, this needs to be stored somewhere else. So after the resultant has to be kept somewhere else. So for that reason, we require a stack. So when we call a function from one to other function, then the function call statement may not be the first statement. So here when I am calling a function to other function, at that time we can't expect the function call statement is the first statement. There could be some other statement before that needs to be stored in the stack. And after the calling the function, we also have to come back from the function area to the place where we have left our control. That means in this, as I told earlier, when I have a calling and called function, when I am sending a input and parameter to the called function, till that needs to be stored in a stack. After the calculation, it has to send the return value or a resultant back to the calling function. So when it is sending, that is also going to be stored in a stack. This is how we are going to make use of this stack concept during the function call. I hope you all understood. It's all regarding chapter 2, stacks. In my coming session, we're going to have a look on this chapter 3. That's all regarding queues. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.